Hello, today's lesson is on concavity. This is the graph of the second derivative, and what can we tell from this graph? We can tell that it's where it's increasing, where it's decreasing, where it's positive, where it's negative, but also whether it's concave up or concave down. If you look at the negative half of this graph, you'll notice that it's U-shaped and facing down. This means that it's concave down, and if you look at the other half, you'll notice that it's U-shaped facing up. This is concave up. So given a function, we can also determine whether a graph is concave up or concave down. So the first step you want to do is find your second derivative. First derivative would be 3x squared minus 6x plus 1. And the second derivative would be 6x minus 6. So next you're going to want to find your zeros. So we'll factor out a 6. It would be 6 times x minus 1. And what will make this equation 0? If x were 1, and we can find that by setting it equal to 0. And solving for it. If we divide by 6, we still have 0. Add 1 to both sides, and x equals 1. Now next, set up a number line. With your 0, and you're going to want to test numbers on each side of 1, your 0. So for this one, we'll just try 0 and 2, nice round easy numbers, and we're going to plug them back into the second derivative. When you plug 0 in, you get 0 minus 6, which is negative 6. Negative 6 is negative. When you plug 2 in, you get 12 minus 6, which is positive 6. Positive. What this means is that from everything left of 1, the graph will be concave down, since it was negative, and everything to the right of 1, the graph will be concave up because it was positive. And that can be written as this. Concave down. From negative infinity to 1. And I'm just going to abbreviate from 1 to infinity. And here's one more example.
In this example, you do the same steps. Start off by finding the second derivative. The first derivative would be 4x cubed plus 12x squared and the second derivative would be 12x squared plus 24x. Then you're going to want to set that equal to 0 so you can factor out a 12. $12x. So that would leave you with x plus 2. Then you set that equal to 0 to find your zeros. You can set each part of your remaining function to 0 to find the separate zeros. So divide each side by 12. And you get x equals 0. And then you set x plus 2 equal to 0. And you'll end up with negative 2. Once you get your zeros, you make a number line. Place both of those numbers on the number line, both of your zeros. And then you're going to use test points around those zeros to find out whether it's concave up or concave down. So I'll use negative 3 here. Negative 1 here. And 1. So first, now you plug negative 3 back into your second derivative after it was factored out. So you get 12 times negative 3 is negative 36 plus and then you do negative 3 plus 2 is negative 1. And that gives you a negative plus a negative gives you a positive. So you get a positive here. And you plug in a negative 1. So you get negative 12 times positive 1. And you get, that gives you a negative. So in between here would be negative. And then you plug in your last point of 1, which gives you 12 times 3, which is 36, and that's positive. So from this you can conclude that concave up, I'm going to abbreviate, would be from negative infinity to negative 2, and also concave up from 0 to positive infinity, and concave down in between negative 2 and 0. And that's a general discussion of how to do concavity. Thanks for watching and hope you learned.